Last minute revision, concentration of solutions in the chapter solution, molarity, RITY, RITY. So this we can remember for liter, right? Molarity, liter, right? The number of moles of solute present in 1 liter of solution. That is called the molarity of solution. It is temperature dependent, right? That is number of moles, m is equal to number of moles of solute by volume of the solution in liter. That is capital M, that is molarity. And molarity means LITY. LITY, we can remember LITY here. It is for solvent in kg. The number of moles of solute present per kg of solvent is called molarity. It is temperature independent. So small m is equal to number of moles of solute by mass of solvent in kg. Mole fraction is nothing but ratio of moles of components to the total number of moles. That is called a mole fraction. Henry's law. Henry's law is nothing but the partial pressure of the gas in vapor pressure in vapor phase is proportional to the mole fraction of the gas in the solution. The partial pressure of the gas in the vapor phase is proportional to the mole fraction of the gas in the solution. That is P is equal to kH into X. kH is nothing but a Henry's constant. And application of Henry's law, where we are applying the Henry's law, the packing of soda and soft drinks. Under high pressure, the gas is more soluble. Under low pressure, the gas is less soluble. And in deep sea diving, in filling the scuba diving tanks, helium 11%, 11.7, nitrogen 56.2%, and oxygen 32.1%. And the function of lungs, and at the heights, people are suffering from anoxia. Anoxia in the sense they are unable to think, they are unable to wake because of lack of supply of oxygen to the brain. So these are the applications of Henry's law. And vapor pressure. What is the vapor pressure? The pressure exerted by the vapor. The pressure exerted by the vapor. That is called vapor pressure. What is Raoult's law? The vapor pressure of any volatile component in the solution is directly proportional to the mole fraction. So vapor pressure is directly proportional to its mole fraction. So that is Raoult's law. And there are two types of solutes. One is solutions containing non-volatile solute and solutions containing volatile solute. When we apply the Raoult's law for solution containing non-volatile solute, the vapor pressure of the solution containing non-volatile solute is directly proportional to the mole fraction of the volatile solvent. That is P is proportional to XA, or P is equal to P naught into X. Right. That is in the case of volatile solute. In the case of non-volatile solute, the vapor pressure of the solution is directly proportional to the mole fraction of the volatile solvent. Here, the partial vapor pressure of any volatile component is directly proportional to the mole fraction of that volatile component. For example, if P is the pressure of the partial pressure of the particle present in the gas, that is directly proportional to the partial pressure of, that is directly proportional to the mole fraction of that particular component. So Raoult's law says that the partial pressure of any particle or any component is directly proportional to its mole fraction, right? So that is P2 is proportional to X2, P1 is proportional to X2. Then ideal and non-ideal solutions. Ideal solutions, I know that, right? P is equal to Pa plus Pp. And opposite in the case of non-ideal, it does not follow the Raoult's law at all temperature and pressure. And intermolecular forces is same as in the pure components. Intermolecular forces between the molecules will be same as the pure components. Here, intermolecular forces resulting in solution are different from the intermolecular forces of pure components. And here, change in volume is zero while mixing the component. Here, change in volume occurs. Del H is equal to zero here, and here del H is not zero here. Actually, del H will be negative. This will be exothermic, non-ideal solution. When it undergoes reaction, it is exothermic, and ideal solution will be endothermic. And non-ideal solution that shows a positive elevation from Raoult's law. You see the usage: positive elevation from Raoult's law, negative deviation from Raoult's law. Positive elevation, when it gives a positive elevations,